When developing unconventional oil and gas in tight shale formations, the use of hydraulic fracturing, commonly referred to as fracking, is used. In the process, water is pumped downhole at very high pressures to fracture the earth and produce oil and gas. The water contains small amounts of chemical additives such as friction reducers and sand in order to prop open the cracks for production. Most of this water returns to the surface over the course of production. The water contains high total dissolved solids, or TDS, organic contaminants, and heavy metals that require waste treatment. The current practice is Class II deep well injection, though the industry is beginning to treat these waters on-site to reduce trucking, mitigate wastewater handling risks, and increase overall environmental responsibility. The preconditioning process uses chemical additives to precipitate out of solution divalent cations such as calcium, iron, and magnesium, and heavy metals such as barium and lead. The process also removes large amounts of oils and greases. The stream is clarified so that a brine stream of mostly sodium and chloride ions enters the mechanical vapor recompression units. 5,000 barrels of wastewater per day of about 50,000 parts per million TDS will be processed. The residence time for the combined preconditioning tanks is about 1 hour. The mixing tank with baffles will promote mixing of chemical additives with the wastewater to facilitate the precipitation of divalent cations and heavy metals. Flocculants and dissolved oil clarifiers will be added to aid in the flocculation of precipitates and the handling of oils and greases. Lime, sodium bicarbonate, emulsion clarifiers such as rhodylene 111, and an aluminum-based flocculant are added to the mixing tank through these feed hoppers. The oil separation unit removes oils and greases from the process stream. The oils and greases separate to the top of the clarifier tank, where they are skimmed off the top by the rolling units and piped out to waste. Precipitates and sludge waste settle to the bottom of the clarification tank. The sludge is pumped to a filter press where it is dewatered. The clarified brine stream continues for further processing to the mechanical vapor recompression, or MVR, units. The filter press is a plate and frame filtration unit that dewaters the sludge to form two streams, a sludge cake for waste disposal and a clarifying stream to be sent to the MVR units. As the sludge is passed through the unit, the filter frames become saturated with solid waste. These are scraped off during maintenance phases to produce the sludge cake, while brine water passes through the filters for further processing. The clarified brine stream is sent to the MVR units. MVR is an evaporation technique that vaporizes water from the salt and non-volatile components. About 75% of the vapor is recompressed to liquid form, which increases its temperature. This is used for heat integration to reduce the energy supplied from natural gas in the evaporator tank. The two main components for the MVR process are the natural gas-powered compressor and the evaporator tank. The three main components of the MVR truck are the evaporator tank, heat exchanger, and the preheater economizer. The evaporator tank utilizes a natural gas heat source. The clarified brine stream enters the preheater, which uses heat from the MVR distillate. The preheated brine stream enters the evaporator tank, where volatile components and water are vaporized out of the waste liquor, which consists of salts and other non-volatile waste contaminants. The vaporized stream is sent to the compressor. A 1 megawatt natural gas-powered compressor recompresses about 75% of the vapor stream to liquid. The remaining vapor stream is recovered as MVR vapor distillate. The recompressed vapor stream is returned to the heat exchanger by the evaporative tank to provide heat to the liquor. This stream exits as a high-temperature liquid stream. The pressure is dropped to return this liquid stream to vapor, where it is mixed with the original vapor distillate stream. This mixed vapor stream is sent to provide heat to the feed preheater. As the MVR vapor distillate heats the feed, organic waste contaminants in a small amount of water are condensed, producing two streams, a purified water vapor stream and a liquefied stream. The purified water vapor stream is cooled to liquid form before discharge or reuse. This mobile wastewater treatment process can provide an economic, effective alternative to deep well injection, while mitigating the risks of on-site storage and transportation of large amounts of contaminated wastewater. For gas development to continue responsibly, we must conserve water and reduce the volume of total waste. At $3 per barrel of water treated, this process offers an opportunity to take this step towards responsible water management without compromising the profitability of shale gas development.